Hello everyone, this MATLAB script which I have explained in my previous video. In this script I have demonstrated the concept of energy curtailment and calculates the associate energy, waste and cost. Let me first run this program. Here you can see the total curtailed energy and the total cost of wasted energy. So in this program we have overall covered the total curtailed energy in kilowatt hours, the total cost of wasted energy, and a graphical representation of load profile, generation profile, and curtailed energy. So now in this video we are covering the second part to reduce the curtailment and reduce the wasted energy. So this is the second part of this, which is going to be a little advanced than the previous one. So now let's start with the from the start. We are just modifying our basic code which I have done right over here. So this is the part 2. So again we have considered 24 hours, and this is the load profile for 24 hours, demand in kilowatts for each hour. And here is our constant generation, which is 200 kilowatts in each hour. And then we have here find the difference, how many excess amount of kilowatts we are generating, and our load profile is less. So here we have calculate the difference. Let me run the program here. So let me click on step. So right now here you can see the difference, that this kind of excess energy we are generating, which is going to be which is going into the wasted. Here in this code we have we are trying to find the high waste hours. So these are the high waste hours, which is almost every hour is from 1 to 24 hours. All hours are having excess amount of generation. So these are the high waste hours, which are starting from the 1 to 24 hours. Mean in 24 hours, almost every hour we are generating the excess kilowatts which are wasted. And here you can see the numbers which are excess, which are in excess kilowatts. So here we have to display the high waste hours. Here you can see the hours. And here the best part, which we are just now, we are manually adjusting these generation and high waste hours. So adjusting generation profiles. This is the initial generation profile. Okay, and right now we have our initial generation kilowatts. We have copied that to the adjusted generation profile, and here initial generation profile, which we have copied our data from this variable into here. And right now we have every hour, all the hours have excess kilowatts, and then we have manually multiply by the reduction factor. So 0.5 is the reduction factor, which we are going to multiply it. So now let me click on this tab, and so here you can see adjusted generation profile. After the adjustments, means this is the initial generation, and this is the reduction factor which we have to multiply it. So this is the adjusted generation profile, and now we have to the adjusted generation profile, which is here, means initially we were generating 200 kilowatts at each hour, and now we have adjusted 200 kilowatts to 100 kilowatts, and now we have subtract our load demand, which you can see right over here. So when I calculate it, it's adjusted curtailed energy. So adjusted curtailed energy will consider here, if you see the adjusted difference. So right now we have here in between -10, -20, -30. So these are the hours where we have less generation and more demand. So that's why we have negative here. But in the adjusted curtailed energy, we have only took the positive numbers. So these are the positive numbers, means here at these points we have excess generation, and the other hours where you can see 0, at these hours we have less generation and have more demand. So we have to just adjusted curtail energy, so we have to calculate based on that. So then we have to multiply it by 0.10 cents previously, which we calculate, and this is the total wasted energy before, which we are calculating on the difference. So difference variable right now is represent our load demand, which we covers initially, this one, and the adjusted curtail energy is representing the above variable, which we have calculated right over here. So calculate cost saving, just we are multiplying with the 0.10 cents per kilowatt to each variable here, and then here we have display each and everything. So other part is very simple and you can take an idea of it. So let's click on the continue, and here you can see total curtail energy before adjustment we have to 2400 kilowatt hours, and total curtailed energy after adjustments we have 360 kilowatts, and total cost after adjustment, here you can see the cost after adjustments, and we have saving this kind of cost, and from the kilowatts you can see how many kilowatts we are saving. So if I show you through the graph, so here you can see that this one is the before. So in this case the red line initial generation profile, which was almost at the top at each hour, and here we have adjusted the our generation profile, so that's why we have less curtailed energy as compared to this graph. So here in this video I just multiply this thing by 0.5, but let's suppose we have a very big network, and our demand and our generation demand is fluctuates a lot. So at that point, if we multiply it with one factor, just right now 0.5, so if we multiply all with 0.5 or 0.2 or with any other variable, then at the end we have a lot of wasted energy. So that's the part where optimization algorithm comes in. So in next part I will cover how optimization algorithm will give us the reduction factor, and we will try to solve it as easy as possible. So here the best part is the optimization algorithm will suggest us a specific number. So we have a large network and the best cost saving and the best way to reduce our wasted energy. So in next part, which will be the final part, in that part I will show you how you can do this program, how you can reduce the losses and reduce the cost by using an optimization algorithm.